Hello and welcome to the lesson on measures of spread. So your learning goal today is that I can calculate a measure of spread for a given set of data. So we talked about measures of spread yesterday called central tendency, and that particular indicator it's a very common one for sort of your basic statistics and basic analysis, but it is a measure of central tendency. What we're looking at today is measures of spread. So in your note, this is where you'd copy down that definition there, and that's what I'm going to start with at the moment here. So what is measures of spread? These are quantities that tell us how closely data is clustered around the center. So measures of central tendency, we're talking about kind of where is that center of the data. Now we're talking about, in this case today, how far is our particular data from those measurements. So that's the focus here. There are a couple of measurements that fall into there. So we are going to look at standard deviation and variance. That'll be kind of the first quarter of the lesson. We're going to talk about quartiles and interquartile ranges, and then percentiles, and then z-scores. So those are the four measures of spread, or four areas of measure of spread that we're focusing on today. All right. So like anything else, it has formulas that we need to deal with. So standard deviation and variance is the first kind of area that I'm going to focus on. So what is a deviation? A deviation is the difference or distance of any data point from the data you calculate as your mean or your average. So yesterday, or last lesson, we talked about mean, median, and mode. We're going to go back to mean, and we want to know how far is our data from the mean or the average there. So we have a couple of formulas that we need to deal with. So I'm going to go and kind of do a lead in here. So if X is a data point, so I'm talking about any data point that you've collected or marked. So if X is a data point, variance is your mean, okay, minus, or sorry, your data point, that shouldn't be X bar, that's my mistake. So is my data point minus X bar, that's what we calculated yesterday, or it'll be X minus mu, and I'm going to talk about that in about 2 seconds as to what that Greek letter represents. So the formula for standard deviation is as follows. So this is standard deviation here. If we have a population, so if we're talking about a census, if we're calculating, if we have all the students from our school in a survey, if we have all the people in Canada, then we can assume a population, and we'd use this formula here. It is the square root of the sum of X minus the mean, all squared, divided by the number in our population. Okay, and I'm going to put the legend off to the side there in 1 second. If we only take a small pocket of the population, so if we only surveyed a quarter or half of the school, or we only have a certain percentage of Canadians, then instead of that sigma notation, so this is standard deviation for a population, we would just simply use a small s per sample standard deviation. And similar formula, well, it is the same formula, except now we're going to use the X bar, or the mean that we calculated yesterday, and it's over n minus 1. So a couple of things to add in the legend. Sigma, it's standard deviation for a population, and S is standard deviation for a sample. So they are the same thing. They are calculating or representing the same thing. Mu is the mean for a population. Mean for a population. X bar is a mean for a sample. And the ends represent, oops, just going to group them together. So capital N or small n, that is the population size. Okay, so there is your legend that tells you what each of those particular variables involve. Now underneath here I have population variance. So population variance is the average of the squares of the deviation. So when you first hear that, you're not sure what it really means, but basically what it is we take sigma and we square it. So if you look at the two formulas from above, all right, it's related to what I'm going to do now. It's the same formula, except if I square the sigma, what that does is gets rid of the square root sign on the other side. So x minus mu squared over n, and same thing here. So really, it's the same formula. It's just manipulated a little bit, and the information or the data it produces is a little bit different. Now, we're going to be more working with standard deviation. That's our focus. So this is the focus of our particular course. You may have to calculate variance in the homework, but its actual interpretation, we don't use it a whole lot in this particular course. It has usefulness in future statistics courses. All right, now you're thinking to yourself, this is a lot of, the formula looks pretty crazy, and it's going to be a lot of work. And you know what? In the old days, it sure was, because for this first example, determine the standard deviation for the height of people in data management. We used to, in the days of my day, when we walked uphill both ways to school, and we still had dinosaurs roaming, we used to have to find the sum by hand. Then we'd have to find x minus x bar. Then we'd add on another column, x minus x bar squared. Then we'd find the sum of that column, and et cetera, and it carried on and on forever. Now, your main work is entering this data into a spreadsheet. I'm going to move to my computer for a second here. So we're going to go to the Google Sheets. And when we go over to the Google Sheets, I've entered that same data for you already if you open up that file from the classroom. Here's all our people. It's all entered in for us. All those formulas that I listed here, these are for if we're going to do it by hand. You know what? We're not going to do it by hand because the task is tedious. It's not something you're going to do in the future. If you're doing statistics, you're going to use spreadsheets. All right, you can Google this. If you ever need the formulas, you can Google it. You can look up YouTube on how to use those formulas. I'm more interested in you actually doing something with the information. So in Sheets, if you hit equals variance, that's VAR, variance, only one formula pops up. I'm going to find the variance for the data set, done. Okay. So basically what the spreadsheet did, it took all the information here, it did all those steps for us, and it plugged it right in for us. Next, we needed to calculate standard deviation, so I'll go back, equals ST, and there it is there, STDEV, standard deviation. Click on it, highlight it, and there you go, the standard deviation is 17.9. Now this used to be like, and I am being serious, this is like a 15-20 minute homework question in the old days. Now for you guys, it is as long as it takes you to enter in that data. There you go. It is done. So now I'm going to do a quick copy and we will paste it. We can answer the rest of this question. Shrink that down. And you're going to run into a lot of purists, maybe teachers in the future that say, no, you shouldn't, you should have to do it by hand. You know what? In the big picture, if you're going to do statistics in the workplace, you're not going to do that all out by hand. You're going to use spreadsheets. So I think it's a good practice, entering the data and working with the spreadsheet. And like I said, Google Sheets works very similar to every other spreadsheet program out there. So first example, determine the standard deviation of the height in data management. So therefore, SD for standard deviation is 17.9 centimeters. Done. Now, class from last semester, MDM4U. It has a mean or an average of 180 centimeters and a standard deviation of 10.5. compare our results with them. So we can see that standard deviation 10.5. That means that the data is clustered tighter to their average. So for the MHF class, we have 10.5 centimeters. So if I put it on a scale here, all their data is within that range. MDM4U, in comparison, our range is right there for the standard deviation. So we can conclude that, therefore, the MHF4U class have a more narrow range of heights. Okay, so that standard deviation, it tells you how tightly clustered your data is around your average. Okay, now our average, I didn't calculate it on the other side here, but if I recall, our X bar or our mean, I think it was around 170 if you plug that into the spreadsheet. So what it's basically saying is that standard deviation, theirs is right here is 180, and that standard deviation is 10.5. So it's basically, and we're going to talk about standard deviation in much more detail. We're just looking at the calculations now. But it tells you that a majority of students are within that range or a lot closer to the mean. So it just means that we have, or MHF4U students are more uniform in height. All right, so I'll leave it there, and I'll see you in the next video.